Now I want to expand on the gas law by looking at the subject of the ideal gas law. The ideal gas law. This is the formula here. PV divided by T equals C, where P is the pressure in pascals, V is the volume in meters cubed, C is a constant which I'm going to come on to, and T is the temperature measured in Kelvin. This means that it's constant. Yeah, that's all it means. This is constant. Now this constant here depends on the amount of gas used. Obviously, if you have more gas, it will take up more space. Now, the amount of gas present is measured in moles and is denoted as N. N is the number of moles. So the constant then becomes NR. R is called the molar gas constant, and the value of this is 8.31 joules per mole per Kelvin. Okay, that's the molar gas constant R. So therefore, the formula now becomes PV divided by T equals NR. By transposing, you can get this. PV equals nRT. This is known as the ideal gas law. This is known as the ideal gas law. The good thing is I'm going to go through an exercise to understand how you can apply this. PV equals nRT. Don't forget, P is the pressure, pascals. V is the volume, meters cubed. N is the number of moles. R is the constant, which is 8.31. And T is the temperature in Kelvin. So that's the ideal gas law. Now another fact that you need to know is that 1 mole of any gas contains exactly the same number of particles. So 1 mole of nitrogen gas has exactly the same number of molecules, isn't it, as 1 mole of hydrogen gas. Do you understand? 1 mole of any gas has the same number of molecules. And the number of molecules in a mole of gas is called the Avogadro's constant. And this is denoted here. What is the value of this? This value is 6.02 times 10 to the 23 particles per mole. So 1 mole of nitrogen will contain 6.02 times 10 to the 23 particles. 2 moles of hydrogen contain 12.04 times 10 to the 23 particles. Let's do an example using the ideal gas law. A flask contains 0.09 kilograms of nitrogen. The flask has a volume of 0.02 meters cubed and is at a temperature of 20 degrees C. What I want you to work out now, first of all, is I want you to state the number of moles of nitrogen in the flask. I want you to state the number of molecules, the actual number of molecules of nitrogen in the flask. And I want you to say what is the pressure inside the flask. Let's go through this exercise. How many moles of nitrogen in the flask? Well, the molecular formula of nitrogen, N2, that's molecular formula, is 28. Yeah, it's 28. Because the nitrogen molecular mass is 14, so it's 28. And therefore, 28 grams of nitrogen is 1 mole, 28 grams. Now, we've got 0.09 kilograms here, or 90 grams. So we've got 90 divided by 28. We've actually got 3.2 moles of nitrogen. That's what we've got, 3.2 moles of nitrogen. The second part of the exercise is how many molecules. Well, we know that it's 6.02 times 10 to the 23 per mole. So you times that by 3.2, it comes out at 19.264 times 10 to the 23 molecules of nitrogen in that flask. That's actual particles in there. The final part of the question asks us what pressure will be inside the flask. Well, this is where you come to your ideal gas law. PV equals nRT. You transpose it because you want to work out the P. P equals nRT divided by V. Well, if you put in all known variables, we know the variables, you put them in, it comes out at 389,104 pascals. That is the pressure inside the flask. Now 1 bar is approximately 100,000 pascals, so this is about 3.89 bar. That is the pressure inside the flask. Let's do another example. A cylinder contains 0.12 kilograms of hydrogen. The cylinder has a volume of 0.035 meters cubed and is stored at a temperature of 120 degrees C. I want you first of all to state the number of moles of hydrogen in the cylinder. I want you to state the number of molecules in the cylinder. And I want you to also work out what is the pressure inside the cylinder. Let's go through this exercise. How many moles of hydrogen are in the cylinder? Well, the molecular formula of hydrogen is H2, and therefore 2 grams of hydrogen is 1 mole. So 2 grams is 1 mole. We have got 0.12 kilograms, or 120 grams. So we've actually got 60 moles of hydrogen. It's quite a lot, 60 moles of hydrogen. The second part of the exercise asks us how many molecules, or actually particles of hydrogen are in there. Well, it's 60 times 6.02 times 10 to the 23, which is 361.2 times 10 to the 23 particles, actual molecules, inside that cylinder. The final part of the question asks us what the pressure would be inside the cylinder. To calculate this, we use the ideal gas law. PV equals nRT. We transpose this to give P equals nRT divided by B. Then all we do is we put in the known variables, as you can see here. We know all this information. And it gives us 33,703,365 pascals. Now, 1 bar is approximately 100,000 pascals. So that pressure is about 33.7 bar. That's the pressure inside the cylinder.